Hello, I'm Kelly Swanson, and this video is about the DARKLIGHT filter. I invented this filter in order to help me find maps that had been erased or painted over, and so I began testing it with Google Maps in the 1587 map. And my filter worked a little bit, but I wanted it better. So I continued on it, and voila. Yes, they covered up maps back in the day. It most likely was monasteries and stuff, but not sure. Anyways, so I decided to take it even further and start examining Hubble images for depth and filling in those necessary needs of depth. And as you can see, I was able to see texture and pull back the dirt and look behind other areas. And it was just a matter of time until the James Webb Space Telescope came out with its deep depth. And this allowed me to go even deeper, exploring what the internal processes of comets and nebulas and everything, to the point of seeing how it's foundationally put together and functioning to generate energy. So when I created these filters, I used a process that is formulated in Isaac Newton's optics. He worked with prisms, and he developed this theory. And I've taken the theory along with math from both him and Hawking's and several others and combined this. So what you're about to see is a very updated version. There are 3 comets in the screen all the time, one flying through and then these 2 that are over on the side there. This is the original. So as you can see, coming out of the lower left corner, that's where we're headed from. So I made some basic adjustments just to see if I could open it up a little wider, basically. And yeah, you can see them coming in and flying past. And then I worked a solid couple of days on this, and now I present to you some newer DARKLIGHT filters. The first one is called Colorific, and it uses color filters to expose and show details that might otherwise go unmissed. It's increased the visibility so you can see more going across the screen. It also shows the tail of the comet that flies by so that you can see the dust going off of it. Now you'll notice as you watch this video in different lights, you're going to see that comet fly by and then disappear. It's disappearing outside of the sort of vacuum that we are in as a planet. We generate an enormous amount of electricity around us. So seeing this and then having it just disappear off of like it's hitting a wall, that's exactly what it's doing. And out and about in the farther distance, there are things flying by that are crisscrossing, and you can see them pop just ever so slightly, zipping across under certain light. But you can really see the tails, and that was the thing, is seeing the tails. Everybody's used to seeing a comet tail. They're not used to seeing a comet snowball. They've heard about them, but they haven't seen them. And essentially a comet snowball is a dirty snowball that's packed tightly. We don't know how long they've been floating around or being spit out, but they're out there. This is deep dark. This is another filter that I built, and it takes it even deeper and it adds in a little bit more depth to it. This is a combination of Adobe AI with my eye, and I've slowed it down so that you can see the tracer lights and the interactions, because when these things are streaming by really quick, you can't, what you may see as a blip on the screen may actually be something else. So watching these and looking at them in slow motion allows you to see the trail and to see it change over time. Oh, there was one that we didn't see before. That's kind of the nice thing about the deeper structured AI is you get more depth into it. And as time goes on, this model will get better and we'll see farther out. But it takes a lot of processing power to dig in deep and extract layers and layers of contrast, because it's all recorded there, but it's all recorded in a way that we've made cameras for hundreds of years. The thing is, we need to build a new type of camera, and that type of camera will be able to see farther in real visible light. But what we have to do is we have to record the light that's being given and turn that into something tangible, which is what these filters are doing. They're providing a more detailed look at the objects, because with quantum energy, something can be there, but it shows no pattern of solid. You know, it's not solid to the eye, but it's actually there. It's a temperature, or it's a heat, or it's an energy flux. And they're showing up out here in different inverse squares and round globs. But I hope you enjoyed this. These are the different ones. Feel free to watch it and pause it. You'll see how the colors interact with each other. And I hope you enjoy. Thank you for watching.